Hello, this is video 22. I'm going to go over Newton's third law of motion. This one is going to be more conceptual. There are not going to be any problems that we do using this one, so it's going to be a short and sweet video. So Newton's third law, you may have heard of it as the action-reaction law. What it says is that for every force that acts on an object, there's a reaction force on a different object that is equal in magnitude and opposite in direction. Notice that I've underlined different. It's really an important keyword here. So as you can see in this picture, this box is in contact with this one. Boxes A and B are in contact. Box B pushes on box A just because of the fact that it's in contact. So this is what FBA says, the force exerted by B on object A. Likewise, the object A pushes on object B. There's a force of A acting on B. So that's the notation here with the subscripts. The first subscript is the person doing the action. The second subscript is the person receiving the action. So Newton's third law says that these forces must be equal in magnitude. They have the same strength, but they're in opposite directions. And they act on different objects. You can see this force acts on object A. This force acts on object B. So the best way to figure out what your action-reaction pairs are in a problem is just simply to switch the order of the subscripts. Another way that I like to think of Newton's third law is that you cannot push without being pushed. If object B pushes on A is going to push on B. You can do this experiment right now. If you push down with your hand on your desk, the desk pushes back on your hand. The harder that you push on the desk, the harder the desk pushes back on you. So you can really feel the effect of this force, of this law. And another way to think about this is that force comes in pairs. And we saw this in the definition of force. We said forces are interactions between objects, that you can't have a force for just one object. There's got to be two objects, two things, one doing the action, one receiving the action. So let's do a your turn here. A small sports car collides head-on with a massive truck. Which vehicle experiences the greater magnitude force during the collision? So your instinct might be, oh, well, the car is going to get beat up, the car is going to get more force. But Newton's third law says the forces must be equal, just opposite direction. If you've got a car here and a truck, then the car pushes on the truck pushes on the car. You can call this the force from the truck on the car. You can call this the force from the car on the truck. The subscripts are switched. The forces are identical, just in opposite directions. So the answer is the same. Now, what is different, however, is that one of them experiences more acceleration. The car experiences more acceleration. So the forces are the same, but force is equal to ma from Newton's second law. So one way you can think of it is, well, the car has a small mass, the truck has a big mass. So in order for these two to be equal, the acceleration here has to be big, the acceleration here has to be small for the truck. Let's do one more. This question comes up all the time. What is the reaction force to your weight? So a lot of you guys are going to think, well, weight is down, so the floor pushing up on me would be the reaction. But please do not make this mistake. You really have to think about what is causing this force, right? If you're over here, I'll just draw you as a ball, and you have weight, remember, well, maybe you don't know this yet, but you'll learn soon. The weight is due to Earth pulling on you. This is the Earth here. So your weight is the force from the Earth pulling down on you. So what's the reaction force? The best way to find that reaction? Just switch the subscripts around. That means that the Earth is actually being pulled up by you, the force from you on the Earth. So the answer is actually A. And you might think, well, the Earth is not getting pulled up by us. It's the same thing as the previous example. The forces are the same, but the accelerations are very, very different. Earth is very, very massive. It's going to have a very, very small acceleration that we're not going to be able to notice. And the last thing is an example, but it's just really a conceptual thing. To review the 3 laws, which law is it? You leave your textbook on your desk at night. It's still there in the morning. Well, this is Newton's first law. An object at rest remains at rest if there's no net external force acting on it. Number 2, a golf ball hit with a golf club goes farther than a baseball hit with a golf club. A golf ball is less massive than a baseball. So less mass, when mass is small, that means the acceleration is big. The mass is bigger, the acceleration is smaller. So this is an example of Newton's second law. Number 3, a bowling ball continues to roll until it hits something. This is Newton's first law. Object moving will keep moving unless there's a net external force acting on it. And number 4, a rocket moves upward when the exhaust gases move downward. Well, you can see this is Newton's third law because the rocket is moving upward, it's pushing down on the gases, and then the gases are what are actually pushing the rockets upward. So this is all for Newton's third law, short and sweet. Remember that for this action-reaction law, the force acts on different objects. That's really a key thing. And the best way to figure out which objects apply, just switch the order of the subscripts. If force A is acting on B, then force B is acting on A.